The next topic is Stokes Theorem. The screen is visible, audio is clear?
Yes, sir.
Yes, sir.
Still joining, huh? And statement of Stokes theorem is, if SB an open surface, bounded by a closed curve C, bounded by a closed curve C, and F bar equal to F1I plus F2J plus F3K be any continuous vector function, vector differentiable function, then circulation over C F bar dot dr bar. What is this? Line integral. Okay, left side is the line integral equal to double integral over S curl F bar. Curl F bar means del cross F bar. Curl F bar means del cross F bar dot N bar ds. Right side is what? Integral over S means what? Surface integral. So Stokes theorem gives relation between line integral and the surface integral. Okay, and here N bar is where N bar is as usual unit outward drawn normal vector, and here it is cos alpha I cos beta j plus cos gamma k is unit normal vector, drawn outside the surface, outside to the surface. So the first point is here, the main important points in the statement of Stokes theorem. First one is open surface. SB an open surface, the first condition. Okay, and the second condition, the vector function must be continuous as well as differentiable. Then what is this left side? This is line integral. Circulation over C, F bar dot dr bar is equal to, this is surface integral. In place of F bar dot N bar ds, in place of F bar, what is the term here? Curl F bar dot N bar ds. Curl F bar dot N bar ds. And what is this one? Stokes theorem gives relation between line integral and surface integral. Surface integral. Line integral and surface integral. This is the first point. Another one is what is the main remark here? Green's theorem is, Green's theorem, the starting one. Green's theorem is special case of Stokes theorem. Special case of Stokes theorem. What is the idea here? Hint is here. If Stokes theorem defined in two dimension, that is xy plane, 2 dimension, that is particularly xy plane. See what happens here. Then What is f bar becomes f bar equal to just f1i plus f2j, right? That is nothing but this is f1 of x comma yi plus f2 of x comma yj. This is the vector function. And what is the normal vector? The unit normal vector, the unit normal vector drawn outside to the surface, outside to the surface. What is the surface here? XY plane. What is the surface here? XY plane is what? N bar equal for XY plane. What is the perpendicular vector? This is XY plane. For example, this is XY plane. Definitely perpendicular unit vector is what for XY plane? Is K bar. N bar equal to K bar. Okay. Second point is over. Therefore, what is this become? See, F bar dot dr bar over C is equal to circulation over C F1 dx, sorry, F1i plus F2j dot dr bar. Dr bar, what is r bar? And in xy plane, what is r bar? Xi plus yj only. So this is dxi plus dyj. Dxy plus dyj. So what is this becomes? Circulation over C f1 dx plus simply f2 dy. That is, one can write f1 of dx, f1 of x comma y dx, f1 of x comma y dx plus f2 of x comma y dy. Okay, this is left side. Okay, LHS part. Coming to right side, what is this? First, I have to calculate del cross f bar. Right side, to find right side, I have to calculate del cross f bar. Ijk, dou by dou x, dou by dou y, dou by dou z. And what is this? F1, F2, and 0. There is no z kth component in f bar in 2 dimension. So what is this becomes? I into this part is 0 and this is dou f2 by dou z. What is f2? These are functions of xy alone, right? These are functions of xy alone. So what is this part is also? I can write 0 minus j into dou by dou x. This is 0 and dou by dou z of f1 0 plus k into. Then I will get dou f2 by dou x minus dou f1 by dou y. So finally what I'm getting here? Dou f2 by dou x minus dou f1 by dou y k bar. This is del cross f bar value. Now, what is this value on the right side of Stokes theorem? What is the value? Del cross f bar dot n bar. Del cross f bar dot n bar. So what is this value? Dot k bar. This is dou f2 by dou x, dou f1 by dou y, k bar dot, what is n bar also? K bar. So what is this becomes? Dou f2 by dou x minus dou f1 by dou y. This is over. And therefore Stokes theorem gives, what is Stokes theorem gives? This is circulation over C f bar dot dr bar equal to double integral over s curl f bar del cross f bar dot n bar ds. So on xy plane we have, what is this becomes? F bar dot dr bar. This is circulation over C f1 dx plus f2 dy. LHS part is over. And coming to RHS part, what is del cross f bar? I got it as dou f2 by dou x minus dou f1 by dou y. That's it. ds. On xy plane, what is ds becomes? Already you know, orthogonal projection, evaluation of surface integral. If I take orthogonal projection on xy plane, what is this becomes? Dx dy by n bar dot k bar. And what is n bar here? K bar, right? Here n bar is nothing but k bar. So what is this entire becomes? This is circulation over C, f1 dx plus f2 dy is equal to double integral over S dou f2 by dou x minus dou f1 by dou y dx dy, which is Green's theorem in plane, which is Green's theorem in plane. Okay, in place of R, the region is given as yes. That's it. Okay, so always remember, if I define Stokes theorem in 2 dimension, it is equivalent to Green's theorem. Any doubts in this proof? The proof is important. Explain Green's theorem as special case of Stokes theorem. Okay, it may be a short question. Any doubts? Now, coming to problems. The problem is simple. Yeah, take this. Verify Stokes theorem. Whenever verify is given, then you have to prove LHS value equal to RHS value of Stokes theorem. Verify Stokes theorem for the vector field. For the vector field, f bar equal to 2x minus yi minus yz square j minus y square zk over upper half surface of x square plus y square plus z square equal to 1 bounded by its projection on xy plane. Bounded by its projection on the xy plane. This is the problem. Solution. F bar is given, and let me check whether the surface is open or not. To apply Stokes theorem, the surface must be open surface. So clearly it is upper half of the sphere. Upper half of the sphere, x square plus y square plus z square. So this one. This is x-axis, y-axis, and z-axis. If I take this one like this, this is upper half of the portion of the sphere. So it is an open surface. It is an open surface. First, Stokes theorem gives, define the Stokes theorem. Stokes theorem gives circulation over C, f bar dot dr bar is equal to double integral over S del cross f bar dot n bar ds. Take this as 1. Take this as 1. First, let me take the left side, LHS part. What is this? Evaluation of this line integral f bar dot dr bar. Evaluation of the line integral f bar dot dr bar. Now, when I consider f bar dot dr bar, this, what is the curve C here? The surface is bounded by curve C. Curve C is clearly a circle. Curve C is given, and what is given here? See, upper half of the surface bounded by its projection on xy plane. So let me write first the upper half of the surface x square plus y square plus z square equal to 1 or you write like this: the projection of upper half of the surface, the sphere, in xy plane. What is the xy plane? Means what? Z equal to 0. In xy plane is the circle. Xy plane means what? Z equal to 0 is the circle What is that? X square plus y square equal to 1 is the circle. X square plus y square equal to 1 comma z equal to 0. Therefore, what is C? C is the boundary of the circle. Closed curve. C is the boundary of the circle x square plus y square equal to 1. The first point is clear. What is curve C is clear. Clearly it is given. We have to consider projection of the upper half of the sphere on xy plane. So one by one let me calculate. What is this f bar dot dr bar first? F bar dot dr bar. What is f bar is given as 2x minus yi minus yz square j minus y square zk dot dxi plus dyj plus dzk. Originally this one, but on xy plane, we have z equal to 0. We have z equal to 0. Therefore, f bar dot dr bar becomes what? 2x minus y I, this part 0, z terms are 0 and dz also 0, dot dxi plus dxi plus dyj. So what is this becomes? Just 2x minus y dx you will get. Therefore, circulation over C f bar dot dr bar is equal to circulation over C 2x minus y dx. What is C? Where C is the boundary of the circle. C is the boundary of the circle. Boundary of the circle x square plus y square equal to 1. Now our line integral problem this is. What we did in line integral? Over a circular path means we put parametric equations. Therefore, let x equal to, what is this is 1, a value 1. Actually we have to take a cos theta. So this is simply cos theta. Y equal to a sin theta, right? And dx is required, so minus sin theta d theta, and theta varies from 0 to 2 pi. Theta varies from 0 to 2 pi over the circle. Therefore, circulation over C f bar dot dr bar is equal to, this is theta equal to 0 to 2 pi, theta equal to 0 to 2 pi, and what is this value? What is this? 2x. So there is 2 cos theta minus y sin theta dx minus sin theta d theta. Minus sin theta d theta. So what is this becomes? Minus outside 0 to 2 pi 2 sine cosine, that is sine 2 theta plus minus sine square theta d theta, right? So what is this value now? This is minus, if I integrate first one, this is minus cosine 2 theta by 2, this is between 0 to 2 pi, and what is this is, okay, I will write one more step, minus is here, 0 to 2 pi sine 2 theta, this is what, 1 minus cos 2 theta by 2, 1 minus cos 2 theta by 2. So what is this? Sine is over, minus 1 by 2 means theta by 2, right? This is between 0 to 2 pi, minus into minus plus cos 2 theta integration sine 2 theta by 2 by 4, this is 0 to 2 pi. So what is this value? Minus, so minus 1 by 2 cos 4 pi 1 and cos 0 1 minus 2 pi minus 0 by 2 plus sine 2 pi 0 and this is 0 by 4. Okay, so what is the final value? This value is 0 and this is minus into minus plus and the value is pi. Therefore, what is LHS value? Circulation over C f bar dot dr value is pi, LHS value. Okay, now coming to RHS value. RHS, evaluation of double integral over S del cross f bar dot n bar ds. First, let me calculate del cross f bar. This is I, j, k, dou by dou x, dou by dou y, dou by dou z, dou by dou z. And in f bar, what is the ith component? 2x minus y, jth component minus yz square minus y square z, minus y square z. If I evaluate this, this is equal to I into dou by dou y of this minus 2yz minus dou by dou z of this minus 2yz minus j into this dou by dou x of this value 0 and dou by dou z of this value 0 plus k into dou by dou x of this value 0 and this value negative 1. So what is this value finally? Okay, this is also gets cancelled, right? Yeah, 0 0. So I'm getting just k bar. Del cross f bar value is k bar. Next one, it is given that projection of S taken on what plane? Taken on xy plane. You know how to evaluate? Then how to evaluate surface integral? Del cross f bar. This is f bar completely. New f bar dot n bar ds. What is if I take projection on xy plane? What is this becomes over r? There is no change here. And what is n bar? What is n bar for the surface? N bar, and what is this becomes dx dy by n bar dot k bar mod n bar dot k bar. If I substitute everything, see, without calculating n bar for this particular problem, why? Because already I know what is del cross f bar. It is k bar. When I substitute k bar here, k bar dot n bar dot k bar, both will get cancelled. This is k bar dot n bar dx dy by n bar dot k bar. That is why I am not calculating n bar value. N bar is actually what? Normal vector to the surface phi. Therefore, del phi by mod del phi will be n bar. But no need of that here because both are getting cancelled. That is equal to double integral over r. What is this? Is simply dx dy. What is r here? Where r is the region bounded by what? Circle to, on xy plane, right? R is the region bounded by the circle x square plus y square equal to 1 on xy plane. Simply. So what is this? Is nothing but area of the circle with radius 1. With radius 1. So pi r square is the answer. So what is this value? Pi into 1 square. So pi is the answer. Therefore LHS equal to RHS. Therefore double integral over S del cross f bar dot n bar ds equal to pi. Since LHS equal to RHS, Stokes theorem is verified. Stokes theorem is verified. Okay, this is one problem. And next one. Same logic here also. This is assignment for you. Similar problem. Verify Stokes theorem. Verify Stokes theorem for the vector field v bar equal to, in place of f bar, v bar is given. That's it. 3x minus y 2yz square j minus 2y square zk. Same, in place of 2x minus y, 3x minus y is there, where S is the surface of the sphere. S is the surface of the sphere. Surface of the sphere. X square plus y square plus z square equal to 16, comma z greater than 0, comma z greater than 0. Okay, same. But what is in this problem? Difference is indirectly it is not given. Take orthogonal projection of this sphere on xy plane. But you consider here. You consider. Okay. Int is what? Take projection of S on xy plane. That's remaining problem same. The remaining problem same. Okay. Previously it is 1 here. Now it is 4 square. So answer is what? Take projection of answer is what? 16 pi will be the answer. Left limit and right limit. There is no change at all. And what is C here? Still any doubt? Here C is the boundary of the circle. C is the boundary of the circle. You write as usual steps as I given in the example. Boundary of the circle. See what is the circle becomes x square plus y square equals 16, comma z equal to 0. Okay, then you consider parametric representations. Okay, 4 cos theta, 4 sin theta. Okay, then another one for surface integral del cross f bar, you calculate that. After calculating del cross f bar, and here, and these are the hints. What is phi here? Phi is given as x square plus y square plus z square equal to 16. X square plus y square plus this is only the change, because the surface is given, and what is the surface is it is not directly given the projection of the sphere on xy plane. So you have to take phi equal to this. Previously also you have to consider, but n bar dot k bar terms are getting cancelled. That is why we are not calculated that this n bar del phi by mod del phi. If we calculate this, what you will get? I dou by dou x 2xi 2yj 2zk. These are all hints, not the complete problem. By 2 is common, x square plus y square plus z square. So 2 gets cancelled. You will get xi plus yj plus zk by what is x square plus y square plus 16. So this becomes 8. This becomes 8. Is it correct?
4, sir. 2 gets cancelled.
2 gets cancelled. This is 4. N bar value is over. Then you calculate del cross f bar. You calculate del cross f bar. Then del cross f bar dot n bar you calculate. Next, on xy plane, what you will get? On xy plane, what is this? Del cross f bar dot n bar ds is nothing but double integral over r del cross f bar dot n bar, what is this? Dx dy by n bar dot k bar. Apply this. Okay, and what is r? R becomes circle here, where r is the circle. R is the circle. X square plus y square equal to 16. R is the region of the circle. That's it. You can find it. Answer is what I have given. 16 pi is the answer. You find this. Next question. Only 2 problems are there. Okay. Let me check. You also try this. This is also assignment. Verify Stokes theorem. Verify Stokes theorem for f bar equal to x square plus y square I minus 2xyj taken around the rectangle, bounded by the lines bounded by the lines x equal to plus or minus a, y equal to 0, y equal to b. Okay, this is C. What is this one? 2-dimension. So it is equivalent to Green's theorem. But you have to write the statement of Stokes theorem. Okay. Next one. And remember, this is an xy plane. One more point. ఇక్కడ మీకు వచ్చే డౌట్ ఏంటంటే ఇది ఒకటే. You hint is here. Hint is what is this n bar here? In the evaluation of integral, you need n bar. For xy plane, this plane, what is the unit outward drawn normal vector? Here n bar equal to k bar for evaluation of surface integral. Evaluation of surface integral. Okay, in Stokes theorem. Del cross f bar dot n bar ds. So there n bar equal to k bar. That's it. Next problem. Yeah, this is one more. Use Stokes theorem, not verification. Say this one. Use Stokes theorem to evaluate integral over c x plus y dx 2x minus z dy y plus z dz, where c is the boundary, of the triangle. C is the boundary of the triangle with vertices 2, 0, 0, 0, 3, 0, 0, 0, 6, 0, 0, 6. Solution. Now, not verification here, right? Using Stokes theorem. First, you extract this. What is the given? Circulation over C, x plus y dx, 2x minus z dy plus y plus z dz. From this integral, I want to know what is f bar, because I have to apply Stokes theorem. What is this? Is in the form of f bar dot dr bar, isn't it? So I can write this is x plus yi 2x minus z j y plus zk dot dxi plus dyj plus dzk, right? Therefore, what is f bar equal to? X plus yi 2x minus zj y plus zk. I know f bar now. Therefore, and what is particularly here, this is f bar dot dr bar, isn't it, right? The first one is f bar dot dr bar. Okay, from this I know the value of, by using Stokes theorem, we have, you have to write the statement circulation over C. All these are circulation. Even though it is not given, the curve C is given as closed one. Dr bar equal to double integral over S del cross f bar ds. Sorry, del cross f bar dot n bar ds. Already this is given in the problem. So I have to calculate this del cross f bar. Okay, take this as 1. So del cross f bar now. This is I, j, k. Procedure of calculating del cross f bar. Dou f by dou z, and what is f bar is x plus y, ith component, 2x minus z, and y plus z. So this is equal to, just a minute. This is equal to I into dou by dou y, this is 1, and this is -1, minus j into this part is over, dou by dou x 0 and this is 0 plus k into this is 2 negative 1 negative 1. So what is this is 2i plus k. This is del cross f bar 2i plus k del cross f bar. And what I have to calculate, the surface, this n bar I have to calculate, unit normal vector I have to calculate. For this, here the surface is the triangle bounded with the vertices, bounded with the vertices. What are the vertices? Bounded with the vertices. What are the vertices? 2 0 0 0 3 0 0 0. What is another one? 6. That means what? See, this is y-axis, x-axis and z-axis. So if I consider just rough figure, not original, this is 2 0 0 and this is 0 3 0. Then this is the triangle with vertices, 3 vertices. Triangle with 3 vertices. So this is nothing but tetrahedron in 3 dimension. So what is the equation then? Then x-intercept, y-intercept like that. Then equation of the surface is x by a plus y by b plus z by c equal to 1. So if I take LCM 6, this is 3x plus 2y plus z equal to 6. That equal to 6. This is the surface. The equation of the surface phi is phi. This is phi. Therefore, what is del phi? Del phi is I dou by dou x, j dou by dou y 2j plus k. This is this one. Therefore, unit normal vector. Why I am calculating this phi? To find this one only. Unit normal vector is n bar equal to del phi by mod del phi. So this is 3i plus 2j plus k by 9 plus 4 13 root 14 root 14. Okay, now what is it? Therefore everything is over, everything is finished. So let me substitute. Therefore 1 implies, 1 is what? Stokes theorem over c f bar dot dr bar. What is f bar dot dr bar? It is given as, what is this? X plus y dx plus 2x minus z dy plus y plus z dz is equal to double integral over s del cross f bar. What is del cross f bar? 2i plus k 2i plus k dot n bar 3i plus 2j plus k by root 14 n bar ds. Still now I have not considered any projection. Okay, let us see. This is equal to double integral over s. This is, I can write 1 by root 14 outside, and this is 6 plus 2. Is it correct?
Plus 1
Plus
7.
1, sir.
1 6 k done. 6 plus 1 ds, isn't it right? That is equal to 7 by root 14 double integral over s ds. Double integral over s ds. What is this? Is clearly, if I consider this as a, this as b, and this is c. This is c. Okay, 3 vertices are there. This is equal to 7 by root 14 double integral. That is why I have not considered any projection. Remember this point. Okay, directly what is this is, I am not getting any integrand as function of x by z, just directly a constant. Okay, this is nothing but, what is this? What is the surface? Yes, it is the triangle, area of the triangle ABC. Area of the triangle ABC. Anyone? What is the area of this triangle ABC with vertices 2 0 0 0 3 0 0 0 6? First, what is the area of this triangle with these vertices? Anyone?
3.
If you have doubt, see, I will take another option. R. Take projection, orthogonal projection of S on XY plane. If I take on XY plane, then I need only this now, right hand side integral. Okay. Double integral over S del cross F bar dot N bar ds is nothing but double integral over S del cross F bar dot N bar dx dy by what? N bar dot K bar, and this is R. Okay. Then what happens here? Already we calculated this double integral del cross F bar dot N bar. What is this value? Yeah, exactly this now. Del cross F bar dot N bar value is what? 7 by root 14. Is it correct? Right? So if I substitute all things 7 by root 14 and dx dy by n bar dot k bar. Now, what is n bar dot k bar? Let me show here. N bar dot k bar is equal to, what is n bar? I have already had 3i plus 2j plus k. 3i plus 2j plus k by root 14 dot k bar. Okay, so this is what? 1 by root 14. So you write here 1 by root 14. Correct? Okay. So what is this? Is 7 into double integral over R 1 by root 14. 1 by root 14 gets cancelled. Dx dy. Where? What is R? R is the region bounded by what? Bounded by what? What is this? This one, this phi. I have to consider projection of this one. Projection of this one. Okay, on xy plane. R is the region bounded by, what is the value? It is taken as 3x plus 2y equal to 6 in brackets z equal to 0 on xy plane. On xy plane. That means what? It becomes like this. This is 2 and this is 3. This part. Correct? Okay, this is region R. So area of the triangle, what is the 0, 0, 2, 0, 0, 3 is equal to 7 into area of triangle. Area of triangle, let's take this is OAB. Area of triangle OAB. Now you tell what is the answer? 7
3,
into
sir.
1 by 2 into AB. 2 into 3. Is it correct? Correct? So this is 21 is the answer. 21 is the answer. This is one way. If it is not possible to find this one, okay, 7 by root 14, and here area of the triangle is what? In textbook it is given 3 into root 14. So 21 is the answer. How you got this 3 into 14? Your intermediate formula. You check and try it. Otherwise, other option is there. Or take the projection on xy plane. This is one way of doing. Any doubts in this problem? Okay, this problem what? Not verification. Apply Stokes theorem to evaluate the line integral. So from the line integral, first I got f bar. From the line integral, I got f bar. Then I will apply Stokes theorem on the right side. So del cross f bar I got. For n bar, what is the given? For n bar, I have to find the surface equation. So phi surface equation is this. From this, I calculated n bar value. Then I applied Stokes theorem. I got this one. And to evaluate the surface integral, I have taken projection on xy plane. projection on xy plane. So this becomes this. And as usual, you know, what is R is the region bounded by this one, the line in xy plane. Okay, that is area of the triangle OAB. 21 is the answer. Okay, next problem. Next one is what is this? Yeah, you try this. If f bar equal to 3yi minus xzj plus yz square k and S is the surface and S is the surface of the paraboloid. S is the surface of the paraboloid. 2z equal to x square plus y square. Paraboloid 2z equal to x square plus y square bounded by z equal to 2. Bounded by z equal to 2. Evaluate double integral over S del cross f bar dot n bar ds using Stokes theorem. Using Stokes theorem. Solution. See, evaluation of this integral using Stokes theorem means don't evaluate using this surface integral. If you apply Stokes theorem, what is this is? This converted to line integral. That is application. Applying Stokes theorem. So we have to go through line integral now. Okay. First thing, by Stokes theorem, we have, what is this? Let me write first this, because I have to evaluate this integral by using Stokes theorem. ds equal to, what is this? Is circulation over C, f bar dot dr bar. F bar dot dr bar. And what is f bar dot dr bar? Let me write. F bar dot dr bar equal to, what is f bar is given as 3y3, let's wait. 3yi minus xz, 3yi minus xzj plus yz square k dot dr bar, dxi dyj plus dzk. So this is 3y dx minus xz dy plus yz square dz. This is over. Now I have to calculate what is boundary C. What is boundary C? Here, what is clearly given as? Here, the surface S. The surface S is the what is the given is surface S is the paraboloid bounded by z equal to 2. Surface S is the paraboloid. What is that paraboloid? Z equal to, given as 2z. 2z equal to x square plus y square. Bounded by z equal to 2. Bounded by z equal to 2. Then what is this? Is nothing but saying, if I draw a rough figure for this, just completely rough figure, not pure exactly. For this, if I put at 0, 0. When z equal to 0, 0. When z equal to 0, 0. That means this one. When z equal to 1, x square plus y square equal to 2. It is a circle. So it is a small circle like this. Next one. When I put z equal to 2, 4. It's this big one. Next big one. Up to what? Z equal to 2. Z equal to 2 means, let me stop here. Z equal to 2. This is 2. If I take, then this will be like this approximately. Okay, this is z equal to 0, right? Bounded by paraboloid like this. Therefore, what is S is maximum. What is this one? What is this? Then this top one. This is nothing but x, z equal to 2. So x square plus y square equal to 4. Therefore, the surface S is The surface S is what it becomes x square plus y square equal to 4 and z equal to 2 and z equal to 2. X square plus y square equal to 4 comma z equal to 2 and see one more point. How to deal one more thing. You write like this: the surface S is x square plus y square equal to 2z. Again same thing this will be, so don't write this. So bounded by the paraboloid, which is bounded by paraboloid. Therefore, the curve C, what is becomes the curve C is the, what is the maximum? The curve, what is this is the curve C. The curve C is the circle x square plus y square equal to 4. Curve C is the circle x square. So, the curve C is the circle x square plus y square equal to 4, which is the boundary of the surface. Which is the boundary of the surface. The curve C is the circle, which is the boundary of the surface, bounded, varying between what? Varying between what? The circle is from z equal to 0 to z equal to 2. From here to here, it is moving. Okay, the circle is moving here. It is a point circle, and here x square plus y square equal to 4. Therefore, this is the now boundary C is x square plus y square equal to 4. Then, therefore, one implies. Therefore, equation 1 implies circulation, not circulation, double integral over S del cross f bar dot n bar ds is equal to circulation over C. What I am getting? 3y dx x z dy plus y z square dz. Y z square dz, where what is C? Clearly x square plus y square plus 4 and z equal to 0 to z equal to 2. Z equal to 2. And since, z equal to 2, you can write directly y on C means, see, only this one, only this one on C, you write like this. Since we have taken 4 here, z equal to 2. Z equal to 2. Therefore, what is this become? Circulation over C, 3y dx, xz, z value 2 substitute here. We have to eliminate z value. My plus, this is 2, 4z, sorry, 4y, and what is dz equal to? Dz equal to, z equal to 2 means, what is dz equal to? 0. So you will get 0 here. So what this part becomes, this is equal to circulation over C, 3y dx minus 2x dy will be there. Okay. Now, what is C clear now? 2 dimension. Problem completely reduces to 2 dimension. To evaluate it, parametric equations, 2 cos theta, y equal to 2 sin theta, and dx dy accordingly. And theta varies from where to where? Since it is a circle, boundary of the circle, 0 to 2 pi, 3y, 2 cos y sin theta, 2 sin theta, and what is dx becomes minus 2 sin theta d theta, minus 2x, 2 cos theta dy, 2 cos theta d theta. This entire. So what is this becomes? 0 to 2 pi, 3 to 6, 12, minus 12 sin square theta, minus, what is this? 2, 2, 2, 8. 8 cos square theta. This is d theta, right? So this is equal to minus 12, 0 to 2 pi sin square theta d theta minus 8, 0 to 2 pi cos square d theta, right? So I can write this is minus 12, 0 to 2 pi. If I replace theta by 2 pi minus theta, and since square is there, there is no change. So 2 into I can write 0 to pi. Again, one more 2 into 0 to pi by 2 I can write. Sin square theta d theta. Same thing here also, 2 into 2, 0 to pi by 2 cos square theta d theta, isn't it? So this is equal to, this is minus 448, and this is apply reduction formula, 1 by 2 you will get into pi by 2. This is 432. This is also 1 by 2 into pi by 2. 4. This is minus 12 pi. This is 4h minus 8 pi. Minus 20 pi is the answer. Minus 20 pi is the answer. And see, once again, I will explain. What is this? I have to evaluate the surface integral using Stokes theorem. Means convert surface integral to line integral. So I have written the formula Stokes theorem. I have calculated f bar dot dr bar. Then coming to find the scene, see what is the boundary. The surface S is, it is the paraboloid bounded by z equal to 2. So a rough figure I have drawn. And the boundary becomes what? A circle at z equal to 2, it becomes what? Circle. Boundary of the circle, x square plus y square equal to 4, where z value is 2. Where z value is 2. That is why in this integral, f bar dot dr bar, I have substituted z equal to 2 and dz equals 0. Converted to this one. And what is the boundary? Clearly it is a circle. As usual, I can evaluate. This is one model. And this problem, this is important. Apply Stokes theorem. Apply Stokes theorem to evaluate integral over C y dx plus z dy plus x dz. Y dx plus z dy plus x dz, where C is the curve, where C is the curve of intersection of x square plus y square plus z square equal to a square, and x plus z equal to a, and x plus z equal to a. Solution. Now what is this is? Apply Stokes theorem to evaluate this. What is this? Is clearly over C, means line integral. Here, first let me extract f bar, y dx plus z dy plus x dz. I can write this as yi plus zj plus xk dot dxi plus dyj plus dzk. Therefore, what is f bar becomes yi plus zj plus xk. This is f bar is over. And what is C? It is the curve of intersection of sphere and plane. Curve of intersection of sphere and plane. Okay. After this, by Stokes theorem. By Stokes theorem, what we have over C, this is f bar dot dr bar. Actually, this is, you write here, f bar dot dr bar equal to, this is curl f bar dot n bar ds. Curl f bar dot n bar ds. So let me calculate, take this as 1. Del cross f bar first. I, j, k, dou by dou x, dou by dou y, dou by dou z, y, z, x, y, z, x. That is equal to I into this is 0 and this is 1, minus j into this is 1 and this is 0, plus k into this is 0 and this is 1. So minus I minus j minus k. Minus I minus j minus k. This is del cross f bar. Del cross f bar. Now, to calculate n bar, to find, this is important, to find n bar, we need the surface, yes. We need the surface yes. Okay. And what is the given? Clearly is given surface is the intersection of the sphere x square plus y square plus z square equal to a square with the plane. Intersection of the sphere with the plane. What is the plane? X plus z equal to a. With the plane x plus z equal to a. So the figure may be like this. This is x axis and this is z axis and this is y axis. This is sphere. This is sphere. And what is x plus z equal to a? Definitely it is a plane in zx plane. Zx plane. Okay, got it? So if in brackets, if plane cuts sphere, what you will get? If plane cuts sphere, we get what? If plane cuts sphere, what will get? Anyone?
Circle.
Circle. We get circle, right? If you don't have any intermediate, it is there. For example, you take apple, sphere, and one knife. It is a plane. If you cut that sphere with knife, the upper part, what is that? It is a circle. Okay. If plane cut sphere, we get circle, which lies. This is very important. Which lies on the plane. Which lies on the plane. Isn't it correct? So this is the circle. Let me take, this is the circle. Okay, and what is this point? A comma 0 comma 0, and this point is what? 0 comma 0 comma a. This is the circle. And what is the equation of the circle in your intermediate? I think S is the sphere and L is the plane, isn't it? S plus lambda L is circle, correct? Is it correct?
Yes, sir.
But what is lambda? How to calculate lambda? We don't know that, right? Here, in intermediate, to calculate lambda, some condition will be given for you. But here it is not like that. But what is the thing here? This is very, very important. Remember this. What is that? If plane cuts sphere, we get circle. And that circle lies on, this is very important, lies on the plane. Therefore, the circle lie on the plane. What is the plane here? X plus z equal to a. X plus z equal to a. The circle, what is this one? This is now surface. The combination of sphere and plane, it is given as. Clearly it is given. What is the surface? It is the portion of the sphere cut by the plane. That is the circle. So therefore we take the surface. Since circle lies on the plane, therefore we take the surface as phi x plus z equal to a. Surface as x plus z equal to a, because it is not possible to find the equation of the circle, but the circle lie on the plane. Therefore, what is del phi now? I dou phi by dou x, j dou phi by dou y, plus k dou phi by dou z by root 2 you will get. So you will get I plus k by root 2. Right? Del phi, still any doubt? I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z equal to this. Okay? Right. Now del phi is over. Oh, no. Why root 2? Root 2 will not be there. I plus k is there. Therefore, n bar equal to what? Del phi over mod del phi. Now this is I plus k by root 2 will be there. Okay. Now, therefore, equation 1 implies, what is 1? Circulation over C. What is the given? Y dx plus z dy plus x dz is equal to double integral over S. What is del cross F bar? We have calculated minus of I plus j plus k. Del cross F bar is what? Minus I am taking outside I plus j plus k dot I plus k by root 2. And the ds will be there. Ds. Then that is equal to minus 1 by root 2. And what is this? Double integral over S, I into I 1, k into k 1, ds. That is equal to, this is minus 2 by root 2, double integral over S ds. What is S? Where S is the area of, or region, surface or area of circle. Area of circle. Now this is, in this figure, I need this area. Anyone? Clearly, for this, I don't know the equation of the circle, but I know the diameter of the circle, correct? I know the diameter of the circle. So I will write here, where S is the area of the circle having extremities or having extreme points. What are those? A, 0, 0, 0, 0, A. Okay, that is, what is the diameter? A square plus A square. A square plus A square. Root 2A. Therefore, what is the radius? A by root 2, correct? Radius is given. So this is, I can write, this is minus root 2 into, this is side part. This is explanation. Minus root 2 into, I can write, this is what? Area of the circle. Area of the circle with radius how much? With radius A by root 2. Okay. So minus root 2 pi r square. So what is this becomes? Minus root 2 pi square A square by 2. Right. So minus pi square A square by, no.
Sir,
no
only
pi
pi,
square.
sir, not pi square.
Okay, madam. Minus pi A square by root 2. Okay. This is another model. Any doubts in this problem? So problem to problem, there is some variation is there. Please observe that and practice these problems. Okay. Now you take assignment. Verify Stokes theorem. Already it is given. No problem. Use Stokes theorem. Use Stokes theorem to evaluate del cross F bar dot N bar ds. Actually, this must be there. Make a mistake. ds, where F bar equal to yi plus x minus 2 xz j minus xyk, and S is the surface of this sphere. S is the surface of this sphere. X square plus y square plus z square equal to a square above xy plane. above xy plane. Second one, if S be the surface of the sphere, S be the surface of the sphere, x square plus y square plus z square equal to 1, prove that integral over S curl f bar dot n bar ds equal to 0. Curl f bar dot n bar ds equal to 0. Next one, next problem. Verify Stokes theorem. Verify Stokes theorem. Verify Stokes theorem for f bar equal to you take y minus z plus 2 I plus yz plus 4 j minus xzk, where S is the surface of the cube. S is the surface of the cube. X equal to 0, y equal to 0, z equal to 0, x equal to 2, y equal to 2, z equal to 2 above the xy plane. Above the three problems are enough. Remember, all of you, in this second problem, see, Stokes theorem is applied on what? Applied on what? Open surface. Remember this point. Stokes theorem is applied on open surface. But what is here? Surface is sphere. Directly it is given as sphere. Sphere means it is a closed surface. Sphere means it is a closed surface. For the second problem, hint I am giving. Anyway, it is one indirect problem is solved in textbook. If S is any closed surface, then in double integral over S, curl f bar dot n bar ds equal to 0, closed surface. What we have to do, for example, this is the sphere. You cut the sphere to open it. Madhyalo cut cheyandi. Okay, anti-clockwise direction. Okay, so this is one part. This is one part. And this is another part. Two parts. Done? Okay, cutting. This is this direction and this is this direction. Okay, clear? Okay. So this is over S1. This is sorry, not this. This open surface. Now this becomes open surface S1 and surface S2. Open surfaces are here. So one direction. So what you will write? Double integral over S f bar dot n bar curl f bar. This is equal to, you write like this, del cross f bar dot n bar ds1 double integral over s2, same thing dot n bar ds2. So both are same surfaces, equal halves, both are equal halves. Okay, and using what is this curve C? This is curve C and this is curve C. Done. This is C, this is C. Take this one C1 and this one C2, doesn't matter, but both are in opposite directions. So using Stokes theorem, what this becomes over C minus this is over C. Both are same but in opposite direction, therefore equal to 0. Equal to 0. This is the hint to apply Stokes theorem over a closed surface. Over a closed surface. Okay, you solve these problems. Who is that? Nagakshita, are you there?
Sir.
You solve the assignment problems.
Okay, sir.
And one more girl, front bench, second one. ఏం పేరు అమ్మాయి? ఫ్రంట్ బెంచ్ లో సెకండ్ కూర్చుంటావు నా లెఫ్ట్ హ్యాండ్ కి.
Rajeshri.
రాజశ్రీయా?
Yes, sir.
ఓకే, తను కూడా చేయమని.
Okay, sir.
అండ్ శ్రీనిజ.
Yes, sir.
ఓకే, బాయ్స్ లో ఎవరు ఉన్నారయ్యా? హేమంత్, హేమంత్